Okay, so for today's lesson, we're going to look at writing equations of sine, cosine, cosecant, and secant functions. So we're going to see two types of problems today. We're going to see one where we give you the graph, and we will write an equation for that graph for whatever trig function we want it to be. And then we will have some where we just give you some information. No graph, I just tell you what function I want, maybe about the horizontal shift, the period, etc. Just give you given information and we just write the equation from there. And that's going to be the first two examples we see today. So let's jump into those two examples and then we'll look at the graphs. So the directions here say write an equation for the graph with the indicated trig function. Okay, so number one says sine, we want it to be a sine function. We want it to have a horizontal shift of pi to the left. We want it to be reflected. We want it to have an amplitude of 4 and a period of 4 pi. So what I'm going to remind us of is this piece right here. We wrote this down in our notes on the second day of graphing. So when I go to write the equation, I like to list out this information, and this is what I need to find, is I need to find my A, my B, my C, and then the D's. And then once I have all that, I can just plug it into that equation. So, first thing, it has a horizontal shift of pi to the left. So C is all about our horizontal shift, and if we go pi to the left, then our C is going to be negative pi. Then it says that it's reflected. Remember with reflections, A would be negative. So I know that's going to be negative. It tells me I have an amplitude of 4, so that means that A value will be negative 4. Amplitude is always positive. That's why we had to indicate that it was reflected, so it would become negative. It has a period of 4 pi. The period comes from B. So what I'm going to do is say 2 pi over B equals to the period, which is 4 pi. Okay? So if I cross multiply this, I get 4 pi B equals 2 pi, because my goal here is to solve for B, so I can plug that into the equation. Well, the pi's cancel out, divide by 4. B is 2/4, which is 1/2. It doesn't mention anything about a vertical shift, so we know that there's no vertical shift, so we won't have that D there. Okay, so writing the equation, of course we don't forget our y equals. My A value is negative 4 sine 1/2. X minus negative pi would just be plus pi. And there is our equation that matches that information. Okay, moving on to number 2. This is a secant function. So I'm going to bring in this so we can do the same thing here. This has a period of pi, an amplitude of 1, a vertical shift down 2, a horizontal shift of 1/3 to the right. So just like I did in the last problem, I'm going to list out A, B, C, and D. This is what I do for all of these problems, even when we get to the graphing ones. I list those out and just fill in what I need. So, a period of pi. So, for secant, the period equals 2 pi over B. I set that equal to what the period is, which is pi. Okay? Cross multiply. The pi's cancel out, so B equals to 2. So I've taken care of that. Then it says the amplitude is 1, so my A value is 1. It has a vertical shift down 2. The D at the end is all about the vertical shift, so down 2 means minus 2. Horizontal shift of 1/3 to the right, so you would be at positive 1/3. Okay, now that we have A, B, C, D, let's plug it in. Again, don't forget the y equals. We don't need to put the 1 there, that's understood. But secant 2 x minus 1/3, close parentheses, minus 2. And there's our equation for that function. Okay, let's move on to reading graphs. So, if we look at this graph, we're going to write the equation for a sine function and then for a cosine function. Now, there's infinite ways to write an equation for this, but really looking at this graph, there's multiple answers you could give me because I don't specify where the horizontal shift is, and so that, depending where you put your horizontal shift, it can change some stuff, and we'll talk through that. But when we talk about shifting from sine to cosine, we'll see what that looks like because we get a lot of the information once we generate the sine graph that what is going to change when we go to write it for a cosine graph. So let's start with sine. So just like I did in the last problem, I'm going to list out A, B, C, and D. So when we think about graphing, we have to pick a horizontal shift. So for this, we have to pick a starting point that is in the middle. Sine always starts in the middle. So I'm going to highlight my axis so I can kind of visually see this better. So I need to pick my starting point. So I have multiple points that are in the middle, right? And you could pick any of these. Unless I specify, you can grab any of those points and use them as your starting point. But looking at it, the easiest one to pick is 0. I'm going to pick 0 as my starting point. So that means I have a horizontal shift of 0. So my C value is 0. So this is where I'm starting for my sine graph. Looking at this, if I put my dashed lines in, that middle dashed line is going to be about my vertical shift. So that middle dashed line is sitting at +1. That means I have a vertical shift of 1. So the D value is 1. The distance between the middle and top line or middle and bottom line is 2 units. So that is going to be my amplitude is 2. Since from our starting point we were going up, that's a +2. Okay, the last thing we need to find is the period of this graph. So to find the period of the graph, you can find it middle through the top and the bottom back to the middle, that distance, or you can find it by going top back to top, middle back to middle. Now, for this graph, the period of the sine and the period of the cosine graph will be the same. So if you're like, well, it's a sine graph, I have to start in the middle and go through the top and the bottom back to the middle. You don't have to do that. I always just pick what are the easiest ones that are distinct points. So, and for this one, it does happen to be the sine graph, where you go middle, through the top, through the bottom, back to the middle. So here is one period of the graph. You have to go middle, top, bottom, middle. Okay, so I need to find how much do we cover here. Well, I only label this tick mark right here, 4π/3. Well, let's look at this. So that's 0. So 1, 2, 3, 4. That is the 4th tick mark. So if I take 1/4 of 4π/3, that would be just π/3. So every tick mark is worth π/3. And then this is just 3π/3. So the period of the graph, I went from 0 to 2π/3. So the period is 2π/3. That's what the period equals. Well, I set the period of the graph equal to 2π/b, which here it's just easy to see, well, since 2π, b must be 3. You can cross multiply and get this same thing, but there's my b value right there. So let's plug everything in to write our sine graph. sine equation. So there's our sine equation. Now, we are going to write the cosine equation. But before we do this, let's take a minute and talk about what changes when we go to write from sine to cosine or vice versa, and then the same stuff is true for secant to cosecant. So, real quick, little sidebar. What changes when we go to graph from a cos graph to a sine graph, or a secant graph to a cosecant graph, or vice versa? So let's talk about A, B, C, and D. A is all about the amplitude. The sign could change. So the number will not change, but the sign, positive or negative, could change. Could. It's all based on your starting point. B, that's all about the period of the graph. I just said that. Sine versus cosine have the same period, so this will never change. C is the starting point. That always changes because cosine starts at the top or bottom and sine starts at the middle, and the same is true for secant and cosecant. The vertical shift never changes. Okay, so let's go back to that problem. And what I said was that I know the period doesn't change, so my B value has to be the same. And I know the vertical shift doesn't change, so my D value has to be the same. Okay, so I have to pick a starting point for cosine. That always changes. So I have to pick a point at the top or the bottom. I'm going to pick this point right here as my top point. So that falls in the middle of 0, and I now know that that tick mark is pi over 3. So that falls in the middle. So I have to take this pi over 3 and cut it in half. So that tick mark is going to be pi over 6, because half of pi over 3 is pi over 6. So my starting point is pi over 6. Now, you could have picked multiple ones here. You could have picked this point down here, this point up here, anything over here, as long as it's a top or bottom point, since that's how cosine starts. Since I picked a top point, my A value will stay positive 2. If I pick this bottom point right here, then that would become a negative 2. Okay, and then let's just plug everything in. And there is an equation for this graph that's cosine. Again, there's multiple from that y'all would likely get, but really infinite answers of the way you could write this. Okay, so we still have a few more examples, so that will continue on the next video.